We're talking about use cases for Tardigrade today. I'm Jocelyn Matthews, the Community Manager at Storj Labs. And with me is Kevin Leffew. Kevin's in BizDev here and spends his days talking and thinking about Tardigrade, which is our open source platform for decentralized cloud object storage. We're the only decentralized cloud storage service to offer an SLA similar to what an enterprise user would expect from AWS or another major cloud provider. Kevin, we want all your knowledge about use cases. Can you break them down for us now?
Yeah, sure thing, Jocelyn. Thanks for the introduction, and hello to our storage community. As we discussed, there are a number of use cases that we're seeing from early customers and partners, as well as just individual developers that are building on the platform, and they tend to be lumped into a few categories. One of the first categories that we saw early on was large file transfer. So Tardigrade is especially well suited for transiting large amounts of data point to point over the internet. High throughput bandwidth takes advantage of parallel packet streaming for rapid transit, and client-side encryption on Tardigrade ensures privacy during transit.
Okay, so we're dealing with large data sets. What are some examples that you could unpack just to give a little exposition on that?
So common examples include large files, academic or scientific data sets. Those tend to be things like FFHQ, which is a large data set for basically people's faces, as well as data sets like GPT-2, which is a data set for machine learning around textual analysis, as well as just general binaries, meaning software downloads or things of that nature. Media collections tend to be things like large collections of video content, storage content. We've seen use cases around, for example, private home security footage, as well as footage recorded by driverless cars and the like. On Tardigrade, developers aren't charged for upload bandwidth, so uploading files to the network doesn't incur any cost, and there are no penalties if you decide to take your data with you and run. For a great example of large file transfer, you can check out transfer.sh. Transfer.sh is a command line tool for transferring files across the internet, and in an average month, transfer.sh is used more than 1 million times to transfer files worldwide. So that's kind of the first use case. And you want me to go on to the second?
Yeah, by all means. We want to hear more.
Yeah, so another really common use case that we're seeing, and this tends to kind of stem from our open source partner program, are database backups. So Tardigrade is really well suited for database backups because when you're backing up a database, which every enterprise or any kind of active software project that has a live database needs to do, you can't store that database in cold storage because if things blow up and you need access to that database quickly, you need it at the snap of a finger. The advantage of Tardigrade is data is available worldwide at half the price of a single availability zone. So that database is able to be rehydrated and downloaded anywhere in the world at the snap of a finger. On Tardigrade, storing backups and snapshots of databases is specifically well suited for the platform. Regular snapshots of databases are basically used for data recovery or for testing, and that tends to be an entrenched part of infrastructure management. Database backups enable you to quickly capture the state of your database at a given point in time, and snapshots enable you to capture the change in the database from the backup to the present, or a diff. On the decentralized cloud, streaming backups eliminates the need to write large database snapshots to local disk for backup or recovery. And in terms of partners that we're seeing that are heavily invested in this use case, ones that stand out are companies like InfluxDB, MongoDB, Kafka, Couchbase, and MariaDB, which are some of the largest open source database companies, which all have Tardigrade connectors that enable developers to store their snapshots on the decentralized cloud through basically the click of the button, just through installing a simple binary.
So great, that's 2 use cases. What are some other ways that it can be used?
Yeah, so another common use case is just general multimedia storage. So anytime that you need to store a large number of multimedia files, whether that's videos, pictures, PDFs, especially data that's processed at the edge from sources like security cameras or driverless cars that must be stored and archived for a long period of time with low but hot access, Tardigrade is a really good solution for that. So rapid transit leverages parallel packet streaming, which makes distributed storage really effective for integrating with video compression systems or in transcoding processes to reduce the volume of data that's stored. Additionally, this multimedia storage is often well suited for low volume content delivery. So out of the box, Tardigrade supports fluid delivery of multimedia files with the ability to seek to specific file ranges, which means you can stream data and you can stream at the byte range of data. So we support basically file streaming. And that tends to be a great use case that is growing in capability and becoming more useful over time as the network and the number of storage and operators on the network grows. But for now, if you have an application with kind of low content delivery needs, we're a great solution.
Okay, thanks. Hey, talk to me a little bit about file streaming versus serving a static website. And I'd also like to hear a little bit about segments and striping and whether that relates to the example that you just gave.
Yeah, sure thing. So segments and striping definitely relate. So basically what file streaming is it's streaming byte by byte data that instead of being downloaded is being streamed from a range of bytes. So rather than downloading an entire movie, for example, you're just streaming the part that you're watching at the moment. And this is what we all do over HTML5 whenever we stream a video on the internet. The interesting thing about Tardigrade is when you upload a file to the network, or actually let's go to when you download a file or when you stream a file from the network, you are calling that byte range from over 80 nodes or 80 peers at the same time. And that gives us a parallel and performance advantage over competitors because we're pulling from all these sources at the same time at a specific byte range. And so because every file is striped, meaning broken up into pieces of bytes on the network, you're able to seek at specific points of a file. So you could say jump to second 31 out of a 2-minute 31-second video, for example.
Okay, thanks. So we've covered a few use cases. I'd like to hear the rest of the use cases, and then after that, I'd love to hear a little bit about how you identified these use cases.
Yeah, sure thing. So the use cases kind of are, they tend to be kind of classic object storage use cases. And what we do is we looked at the kind of the classic use cases and we said, what are the unique capabilities of the decentralized cloud? Meaning, what capabilities can be basically differentiate us from competitors due to our parallelism, concurrency, and the distributed nature of the data that's stored on the network. And from that, we were able to pinpoint some early use cases and validate those use cases with early partners and customers. And so those are some of the ones that we've talked about. Obviously, other use cases that are common are things just like general private data. So because data is encrypted client side before it ever leaves the edge device that it's being uploaded from, private data is a really great solution for storage. And so that makes storage really well suited for things like sensitive contracts or company data that needs to be private by design as well. I think what's interesting about storage is the network has been built to operate in an untrusted environment. And as a result, the most extreme security measures are implemented, which result from client-side encryption. So no one on the network can see your file except for you. Only you have the keys to your data.
Thanks for all that great info. So let's just recap. We've talked already about archival backup. We talked about streaming. We talked about downloading in parallel and large file transfers. I'd like to hear your thoughts on IoT.
Yeah, sure thing. So as we know, IoT devices generate massive amounts of data. And so what Tardigrade is really good at is storing that data basically for basically packing together and storing it. So small IoT files can basically be packed into large blocks for efficient storage, while the individual messages can be accessed via streaming to specific byte ranges, as we discussed. So what that means is using kind of a pub sub messaging tool or an open source streaming platform like Apache Pulsar that's basically designed for IoT devices. Tardigrade's a great solution to snapshot that data and then analyze it because we're data striped and you're able to seek it at kind of the byte range. But obviously there needs to be some kind of intermediary tool that packs that data into one large chunk or one large file, as large static files are more well suited for the network.
Thanks, Kevin. So this is really interesting. I'm hearing a lot of really good technical information from you, but I'd also be interested to hear when you are talking to people about building businesses, how do you explain how Tardigrade fits into that as well? Because solving a technical issue is one thing, but then that technical issue exists as part of a larger business.
Yeah, so when I talk about the value proposition of Tardigrade, I like to focus on three main points that I like to think make kind of a triangle. So the first is obviously economics, and so the fact that we're half the price of the big guys, half the price of Amazon, and even less than half the price of say Google object storage, we're a pretty compelling alternative given the fact that we're designed in a very similar manner. We're in fact S3 compatible through our S3 gateway. And so if you're a company that's looking to reduce operational expenses through cloud storage, we're a really easy, plug and play solution to sub out Amazon S3 and lower your cloud storage bills by half. In addition to the economic aspect, there's obviously the security aspect. One of the kind of major security concerns of 2019 were leaky S3 buckets, and we saw through the Capital One hack and previous hacks through Equifax and kind of similar scenarios where data was misconfigured on the public cloud and made accessible to everyone. And for financial institutions and consumer-oriented data, that's just unacceptable, which is why all data on Tardigrade is encrypted by default at the client side. And so there's obviously, we've talked about economics, we've talked about security, and kind of the third piece of the triangle is performance. And so for a number of use cases, because data is segmented and streamed in parallel, we're actually able to outperform the large cloud providers for certain use cases. So you can imagine if you break a file into 80 pieces, you need any 30 of the 80 pieces to rebuild the file, and then you call all 80 at the same time. You're able to kind of flatten the Poisson distribution of streaming because you're just getting the fastest subset of nodes at a given point in time. And so the kind of the endpoint there is that for large static object content in most parts of the world, Tardigrade tends to be faster and also more predictable, meaning a tighter variance spread in performance than the centralized competitors. And that's due to the distributed nature of the platform.
Thanks. What are you the most excited about in terms of use cases? What excites you the most?
For use cases, well, a lot of interesting use cases. Obviously, I'm a bit of a technology futurist myself, so anything related to say driverless or blockchain or IoT really excites me. But I think where we're really seeing the most traction is snapshots of databases. Given kind of the use case that we discussed, databases and their backups need to be stored in hot storage, not in cold storage, because when you need to access that data or rehydrate a broken or blown up database, you need it at the snap of a finger. And we provide a solution that's globally available at less than half the price of a single availability zone. And so if you're, say, backing up the database and replicating it across North America, South America, Asia, Europe, you're already cutting your costs by more than 1/8 as compared to the centralized cloud providers. And so I think that use case is really exciting, and that's where we're seeing a lot of traction today. Another big use case that I'm personally excited about is our integration with Nextcloud, which is an open source file management tool. So Nextcloud is similar to, say, a Microsoft Teams, where you can host documents, create presentations, create what I use it for mainly is for architectural diagrams, as well as just kind of classic groupware for communication via email, via calendar, and via calling, kind of like in a Skype-like process. We have a connector that enables users to back up Nextcloud, which is a completely open source alternative to, say, Microsoft Teams or Dropbox. And this connector enables users to basically back up that data to the decentralized cloud.
Thanks. And what would you like people to walk away from this conversation knowing about Tardigrade?
Yeah, I mean, I think the most exciting thing is you can get started today and we'll provide free storage. So for users that sign up today, I think they get 50 megabytes of free storage. If you go to tardigrade.io/satellites, you can go ahead and pick the satellite closest to your region and go ahead and get started and try the platform out.
Awesome, thanks. So if people want to get involved, what's the next step? What's the next thing that you would say that someone should do if they're excited about Tardigrade right now?
Yeah, so we have a really robust community. So at forum.storj.io, that's the house for our community. We have a large community of developers. We had over 14,000 developers on our Tardigrade waitlist. And the forum is a place where developers meet each other, talk about Tardigrade, talk about the projects that they're working on, including standard design and integration patterns. We're an open source project as well, and we love community contributions. So over 50% of our GitHub contributions today are from the community, and we want to continue to grow that as the product matures.
Okay, great. So we're coming into the final round, and I just want to ask one more question, which is if someone was going to make a project right now, what would you recommend? Like, what's something fun that somebody could get started with right away?
Yeah, so I think if you're just getting started today, obviously the first thing that you want to do is upload an object. I think uploading a video, tying it to to DNS and streaming it from the browser is really interesting. But kind of the next step after you upload your first object is maybe testing out Nextcloud, which is that open source file management tool that's kind of similar to, say, Microsoft Teams or Dropbox, and using that to upload and download data through kind of a GUI-like experience.
Okay, that's all the questions that I had. Kevin, thank you so much for spending time today. This has been a really great talk, and I look forward to having you back again. And for everybody who's listening, if you've made it this far, thank you so much. I'm pushing out new content to the community every week, so tune into the forum and keep an eye on our Twitter. I'm looking to do interviews, brown bags, deep dives, whatever the community is interested, whatever is developer-centric, and whatever gets folks excited about Tardigrade. If you have ideas about something that would make a great topic, please reach out. You can find me on the forum. My username is Jocelyn, or you can email me. And again, my email is jocelyn@storj.io. Thanks, and see you next week.